Welcome to short presentation on plastic drying shrinkage. So what is shrinkage? Shrinkage is a time-dependent deformation. It is occurring due to the evaporation of concrete surface, and it results in loss in moisture in concrete. Due to this loss in moisture, tensile stress are developed in the structures, and it can form cracking on the surfaces. This is a durability issue, and it can affect the long-term strength in concrete. So what are the different types of shrinkage? We have plastic shrinkage, chemical shrinkage, autogenous shrinkage, and drying shrinkage. So our topic of discussion is plastic shrinkage. What is plastic shrinkage? As the name indicates, it is the concrete is still in plastic, which is not set, and the cracks is starting to develop. That means the concrete is freshly poured, and there is a atmospheric environmental condition in which rapid drying of the surface occurs, and this will result in shrink and in cracking on the surface. These cracks are often 25 mm to 2 meter long, and is usually occurs within less than 8 hours after pouring the concrete. So what are the factors affecting it? Atmospheric temperature, relative humidity, wind velocity, and solar radiation. The most detrimental factor for this plastic drying shrinkage is wind velocity. Higher the wind velocity, higher the plastic drying shrinkage. And also, when the relative humidity is low, there is a chance of plastic drying shrinkage is very high. So as you can see from the figure, this is a concrete surface in which a lot of bleed water is coming out. So the rate at which the bleed water oozes out from the concrete is called the bleeding rate. And when this water is coming out, due to this atmospheric condition, a rapid drying occurs and evaporation on the surface water is occurring. So this rate at which the evaporation is occurring, it is called evaporation rate. When this evaporation rate is higher than this bleeding rate, there are higher chances of plastic drying shrinkage. This can be further explained with the figure. So as you can see, when the evaporation rate is less than bleeding rate, there is no chance of plastic shrinkage. When evaporation rate is more than bleeding rate, the capillary pressure builds up, and which will induce a tensile strength, and this concrete experience a contraction, and there is a higher chance of plastic shrinkage cracking. So ACI 305R99 has proposed a nomograph, which is a combination of three graphs which you have seen in the left side, where it is a function of air temperature, relative humidity, concrete temperature, and wind velocity. From knowing all these parameters, we can find out the rate of evaporation. Its unit is kilogram per meter square per hour. So, and the code has also proposed some equations given in the right side. So, when the rate of evaporation is less than 0.5, there is a less probability of plastic shrinkage cracking. When it is between 0.5 to 1, there is a medium probability. We should be cautious. When the rate of evaporation is greater than 1, there is a higher probability of plastic shrinkage cracking. This is given in the ACI code. The preventive measures are temporary wind breaks, adding evaporation retardants, and fog spraying. This will prevent higher bleeding rate.